Bismillah ar-Rahman ar-Rahim. We will present in sample against out-of-sample forecasts. A common practice to address this issue is to reserve part of the data, as we will do, by not including it in the estimation sample, just to show that the history ends sooner and the reserved data is part of the future or part of forecasts. We can then produce forecasts over the reserved sample and perform forecast evaluation by comparing the out-of-sample forecast values to the actual history. Okay, let's carry out example by breaking down the sample as follows. The estimation sample, we will make it from 1960 month 1 to 2008 month 12, and the forecast sample will be from 2009 month 1 to 2014 month 12. Then we press enter after each command line. Now we need to produce a forecast for the payroll series using the forecast sample. I will open the equation 2, and in the equation box toolbar we should press the forecast button to open the forecast dialog. Under series name, we will name the series equation 2F. Under the forecast sample, we will type forecast sample start from 2009 month 1 to 2014 month 12, and we will set all the other options as we did previously. I mean, we select a graph to forecast and actual forecast evaluation, and we insert actuals for out of sample observations, and we will click OK. We notice that the forecast output is shown here. Let's take a closer look at the forecast evaluation table. We notice that EViews indicates the number of observations used to perform the forecast evaluation. Here we have 72 periods, which spans the period from 2009 month 1 to 2014 month 12. And we note EViews only displays the evaluation statistics over the periods for which actual data are available. Also, the reported forecast statistics indicates that our forecasting model does not perform well in case of out of sample. Let's explain it in detail. The root mean squared error is a standard deviation of the forecast errors. This is quite large when compared to the standard deviation of payroll series. Also, the RMSE root mean squared error and the mean absolute error depend on the scale of the dependent variable, while the next two statistics, mean absolute percentage error and Theil Inequality Coefficient, are scale invariant. Anyway, the Theil coefficient lies between 0 and 1, and if it's 0, it will indicate a perfect fit. So with 0 indicating a perfect fit. We read three indications. The first one, bias proportion, which indicates how far is the mean of the forecast from the mean of the actual series, the relationship between the forecast and actual. Variance proportion also indicates how far is the variance of the forecast from the variance of the actual series. Lastly, the covariance proportion measures the remaining unsystematic forecasting errors. If our forecasts are good, the bias and variance proportions should be small, which is not the case here. And we know that the bias, variance, and covariance proportions add up together to 1. If we add bias proportion plus variance proportion plus covariance proportion, we should get 1. So all of them, they are given as a proportions out of 1. Well, we need now to forecast explanatory variables. In order to be able to produce an out of sample forecast, we need to know the future values for all explanatory, I mean the right hand side variables in the equation. This was easy enough so far because we used trend and seasonal factors to forecast our dependent variable. EViews easily produces forecasts for trend variable and seasonal factors, which are set as month equal 1 and month equal 2, etc. However, for most explanatory variables, we need to provide values over the forecast period. For example, suppose we want to forecast payroll using industrial production, IB, or ISM, and T-bill as additional explanatory variables. As shown previously and in the graphs which appear now. We have provided data for the explanatory variables over the forecast period from 2009 month 1 to 2014 month 12. Now let's define the sample objects by typing the command window like this. We say sample, then sample underscore EST, means estimation, and first, A first, then 2008 M12. This is the first line. The second line, sample underscore 4, 2009 month 1 to last, at last. Now we need to write in the command window sample EST, LS payroll C, IB, ISM, T bill 3 months, at trend, at expand, at month, and at drop last. We press enter. After each command line, the second command should be typed in one line. Okay, we will keep this equation or save it as equation number 3. Now we need to produce a forecast for the payroll series with this model. We will open equation 3 in the equation box toolbar and we press forecast button. The forecast dialog box opens up. In the series name, we will write EQ3F for forecasting in the forecast name field, and under series name, the standard error optional, we can write the name of the standard error series, and this creates and saves a new series called EQ03 underscore STD EV, and this is optional, but we will do it. Under forecast sample, we will type the forecast sample 4, sample underscore 4. The other options, we will set them as follows. We will check forecast graph, forecast evaluation, and uncheck insert actuals for out of sample observations. We press OK. The forecast output is shown as follows. You can see the bias proportion still large, 96 as you see, indicating that forecast is not very good. However, this model performs considerably better than equation 2 because RMSE, I mean root mean squared error, is lower than equation 2, and the mean absolute percentage error is lower as well, 10,000, and even the bias proportion is lower because there 98 I was. Okay, and let's save this as a table 2. Let's finish to this point. We could forecast and explain the forecast evaluation. Thank you.